Hello and welcome to our first podcast. This podcast will review Chapter 4. Okay, so I'm going to go through a few problems that are similar to the ones that will be on your test. Feel free when you're at home to stop and go do something else and then come back and write down some more examples. Okay, so the first example, find the measure of the sides of triangle RST and classify the triangle by its sides. So to do this, we need to use the distance formula and use that between all of our side lengths of this triangle. So if it helps you, draw a triangle, label it RST, so that you know you've found the distance between all the sides. So RS. Okay. RS, 5 minus 2 plus 2 minus 0. All of those squared and under the square roots. And you can go through and simplify that, but you should get equals the square root of 13. Our next side, RT. RT, 2 minus 2. Remember, y2 minus y1. So 2 minus 2 squared plus 4 minus 0. Squared. And if you go through and simplify all of that, you should get the square root of 16. And our last side, we did RT, we did RS, we have TS left. You will need this distance formula for your test, so I suggest you do these so that you can do them quickly on your test and more efficiently. Okay, so TS, 2 minus 5. Plus 4 minus 2. And you should get the square root of 13. So that's only part of this problem. We found the side measures. Now we have to classify the triangle by its side measures. So if you look at our final results here, 2 of them are the same. So if a triangle has 2 sides that are equal side lengths, we know it's an isosceles triangle. So on your test, you would box isosceles, and you would box all of these side measures. Okay, the next problem we're going to do, we're going to find the angle measures of each of the numbered angles in this picture, and we're going to use some different properties that we've been talking about with angles and triangles. Okay, so angle 1. If you look, 80 and 40 are remote interior angles to angle 1. So angle 1 is the sum of 80 plus 60, so 140. Excuse the fly. There's a fly in here. Okay, so I'm going to write this angle measure in there because that'll help me. So angle 1 equals 140. We're done with that one. Angle 1 and angle 2 are a linear pair, so they sum up to 180. So angle 2 equals 180 minus the 140. So that would be 40 degrees. I'm going to write that in there as well. Okay, let's do, what else can we do? Let's do angle 4 next. I like looking for linear pairs and the exterior angle problems first. Okay, so 105 and angle 4 are a linear pair, so they should sum up to 180. So angle 4 equals 180 minus the 105, and that gives me 75 degrees. These are all in terms of degrees. So again, I'm going to write that in there. Okay. From here now, I can find angle 5 because 40 degrees and this 75 degrees are the remote interior angles in reference to angle 5. So angle 5 equals this one plus this one. 40 plus 75. Then you should get 115 degrees. And that leaves us with, I think I still have to find angle 3. And if you look, we can still use that exterior angle theorem here. Here's my exterior angle, 105. and that should equal the sum of this and this. So angle 3 equals 105 minus 40. So angle 3 equals 65 degrees. Okay, so that's what you do on a problem like that on your test. Just find all of those numbered angles. If you want, you can go back through and make sure they make sense to you. Okay, I would recommend that. All right, next problem. Name the congruent triangles. So if you look here, it gave us that all of these various parts are congruent. So we could say that these angles are congruent by side, 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 or angle, side, angle, but that's not what we were asked to do. We were asked to name the congruent triangles. So remember, the order that you do that matters. So I'm just going to choose triangle ABC is congruent to triangle. So angle A over here has the one little dash mark, so I have to start with the angle over here with the one little dash mark. So triangle D. Okay, then on this triangle I went from A to B. I went along the side with the two dash marks. So over on this triangle, I'm going to go along the side with the two dash marks. So D to C. And then that's easy. That just leaves the third point of this triangle, which is B. And I'm done. I've named the two triangles. A test question might say, name the two congruent triangles and all of its congruent parts. If the question said that, you would have to go on and say that, for example, BD is congruent to CA. Okay? This question didn't ask us to do that, so I won't go through and do all of those, but that would be good practice to write all of the congruent parts in these two triangles. All right. Next, verify that the congruence statement is true. So this is our congruence statement. And name the congruence transformation. So remember, this is kind of an aside. There's three congruent transformations that we talked about. Slide, flip, and a turn. So just by looking at this, we know that this is a slide. Okay, it slid from here to here. It didn't flip over any line. We didn't rotate it or turn it. It just slid from one position to another. So this is a slide. So this answer goes with name the congruence transformation. The congruence transformation of these two triangles is a slide. Okay. Now what about the part that says verify the congruence statement is true? Well, to verify that these two triangles are congruent, we can use side, side, side. So we would do the distance formula between all three sides to show that they're equal. So we would do AB equals your distance formula. A is at 1, 2, 3, 4, 5. -5, -3. B is at -3, -1. Okay, C is at -1, -3. And we would do the same thing with A prime, B prime, and C prime. A prime, oops, excuse me, forget that little mark. A prime is 1, -1. B prime would be 3, 1. And C prime would be 1, 2, 3, 4, 5, -1. So that's a good place to start on these problems. Write down all of the coordinates, and now you can start finding the distance between all of those coordinates and all of the segments that you need to prove that these two triangles are congruent. So we would have to do the distance between A and B. Okay? We find that distance, and we do it also between A prime and B prime. So this distance and this distance. And hopefully they're the same. Okay, then we would find the distance between BC and B prime, C prime. And again, hopefully they're the same. And finally, A, C, and A prime, C prime. And hopefully those are the same, okay? If all three sides are congruent like that, then you can say, yep, this statement that the two triangles are congruent is true. And that's your verification by finding the distance.